Assalamu alaikum. In today's lecture, we are going to do our topic salts. Okay, we have done acid, bases, and salts in our previous lectures. Okay, we have done acid. Okay, we have done bases or alkalis, and also we have done integrators, type of oxides, like for example, basic and etc. So now let's do salts because we are done with the two topics, acid and bases. Now we are going to do salts. Okay, so basically, what is the definition of salt? Salt is basically an ionic compound which is formed when an acid is neutralized by a base, okay? Which is formed when an acid is neutralized by a base, or an ionic compound which is formed when H positive ion of acid is displaced by a metal ion. So this is the definition of salt. Now, what is the pH of salt? Are they neutral, acidic, or basic? So basically, salt are neutral, acidic, and also basic. So they are present in all three nature. Okay. So how is salt created? So when a strong acid react with a strong base, what happens is that salt is created. Okay, neutral salt. You got it? Now, how is an acidic salt created? So when a strong acid and weak base, okay, strong acid, weak base reacts, an acidic salt is created, okay, means below 7, which has a pH power of hydrogen below 7, and the neutral one which is equal to 7, okay. And how is a basic salt created? When a weak acid reacts with a strong base, it forms salt, okay, which is basic in nature, means higher pH than 7, okay. So now we are done with the definition of salt and done with pH of salt. So now let's come to ma- uh, salt making. So basically there are two types of salt. Okay, one is soluble and one is insoluble. Okay, soluble and insoluble. For making soluble, there are four processes or four methods for making a soluble salt. What are they? First of all, when we react metal with acid. Okay, then the second one is metal oxide with an acid. Third one is metal carbonate with an acid, and fourth one is alkali with an acid. Alkali basically means that metal hydroxide. Okay, so metal hydroxide or alkali with an acid. So these are the four ways how we make salt. Okay, in the soluble way. Okay, so in this, if there is a calcium, magnesium, zinc, iron, or lead, then only metal will react with acid. Okay, like let's see this periodic table. Okay, so let's zoom it like okay, so let's see the periodic table. In this, we see that these top two, we don't react directly with an acid. Okay, you got it? So why do? Because it's not recommendable, because it's too much reactive. So we cannot do it in a lab or something because it produces explodes. It explodes. Hence, we don't do it in the lab. While we do calcium, magnesium, okay, not aluminium, because aluminium create when it starts reacting, there is an unreactive coating on it, which prevents it from reacting. Okay, so due to this, we don't react it now. And after this, there is carbon, which is not a metal, so hence we don't add it. Then we go to zinc, iron, and lead. So basically, one, two, three, 4, and 5. So these five metals are used in the metal plus acid reaction, and other metals we cannot use. Okay. Now let's come to metal oxide. In metal oxide, all the metals counts except sodium and potassium, because they are not recommendable. Okay. Except for these two, calcium, magnesium, aluminum, zinc, iron, lead. Hydrogen is also not a metal, so hydrogen will also not come. And copper and silver. While gold, what is gold? Gold is basically unreactive in nature. In nature, okay. So hence it cannot react. Now let's come to metal carbonate. So for metal carbonate, which things are needed? Calcium, magnesium, zinc, uh, iron, lead, copper, and silver. And this again, aluminum is not present because it makes a coating. Okay, hence we don't add aluminum. Okay, and then if we come to metal hydroxide, what we see? Plus acid. Basically, they react just with the splan salts, splan metals. We will understand this in later in this session, inshallah. So basically, they are like they only react with lithium, sodium, potassium, and ammonia. Okay, and by the help of titration, okay, which is different, and we will do it in the next lecture. Okay, not in this lecture. Titration we will do it in the next lecture. Okay, so we are done with metal plus acid, metal oxide plus acid, metal carbonate, and metal hydroxide. Now let's come to insoluble. In this insoluble, what happens is precipitation method. So what is precipitation method? So basically, precipitation method is a reaction in which two or more aqueous solution are mixed to form a solid. Okay, so this is the precipitation method, which also we will do. Okay, now let's come to the solubility rule. So the first rule of solubility rule is that splan salts are all soluble. Okay, splan means basically this splan is derived from some element names. Like for example, S means sodium. Okay, sodium. P means potassium. Okay, L means lithium. A means aluminium, and N means nitrate. Okay, so this is just derived from the element. Like here is S sodium. Okay, which has a charge positive. Then here is potassium, which has a charge positive. Then there is lithium, ammonium, and nitrate. Okay, so sodium, there are some examples of a salt, sodium salts. Okay, there's like NaCl, which is a common salt, Na2SO4, sodium sulfate, sodium carbonate. So these all are salts. Now let's come to potassium. Potassium, there is potassium chloride, potassium nitrate, potassium sulfate, and potassium carbonate. So these, and ammonia, Cl. Okay, so these are some examples of these salts. So like if we see sodium oxide, okay, when we react sodium, let's take example of one reaction of this sodium. So if we see sodium oxide reacting with an HCl, it will form NaCl. Okay, why NaCl? Because Na has a positive charge and Cl has a negative charge. So when they will uh, change their position, they'll be both one, and one we don't write. Okay, so hence it will be NaCl plus H2O. H2O means water. Okay, so we are, and we can uh so we are done with the plant salts. Okay, now let's come to the second, chlorine and bromide. What are they? They are basically halide salts. Okay, halide salts. So in this, all are soluble. Okay, all are soluble except silver chloride, lead chloride, and mercury chloride. Okay, except these three, all are soluble in this. Lead chloride, these are the chloride. Okay, and if we come to the bromide, they're basically the same, but like here it's silver bromide, except for like here it's chloride, here it's bromide. Hence, it's easy to learn, and you have to learn this because it's very important. Lead bromide, mercury bromide. Okay, so what are some soluble in this second one? For example, lithium chloride or lithium bromide or magnesium bromide. These are some soluble salts. Okay, now let's come to the third rule, which is that all sulfates are soluble except silver sulfate, lead sulfate, barium sulfate, and calcium sulfate. Okay, except for these four, all of the sulfates are soluble. Now let's go on the fourth rule, which is of carbonate. In this, all are insoluble. Okay, for carbonate there is a rule insoluble, while all other there is a rule that they all are soluble. Why is it? Because it's carbonate. Okay, all are insoluble except carbonate of lithium carbonate, sodium carbonate, ammonium carbonate, potassium carbonate. So these four, because except for these four, or are soluble. Okay, basically, like you may see it like splant plant salts are soluble. Okay, but in this nitrate doesn't come. Only SPLA salts are soluble. Okay, like so we are done with the rules of the solubility until now, and the salt making and the uh, definition of salt and the pH of salt. Okay, so now let's go to an example. How how we will find magnesium chloride. So for finding magnesium chloride, there are some steps. There are some rules basically, or some steps you may say. So the step one is that first determine what reagents or which metal, like which metal oxide or metal carbonate are needed, and which acid is needed. So how we will find this? First of all, we see if the example, like it's magnesium chloride, is soluble or insoluble. So we know that it's soluble. Okay, it's a soluble salt. So we will first think of that in which category does it come? It comes in that magnesium chloride, magnesium oxide, magnesium carbonate. So first of all, we'll try it with magnesium oxide. Why we will try it with magnesium oxide? Because in oxide all the metals come, so hence we don't have to think too much, and we will just write magnesium oxide. Or if here, let's suppose here is a copper, then also we'll write copper oxide or somewhat like, okay. So magnesium oxide we have found, and chloride Cl, it comes in two things. Okay, but we write HCl. Okay, let's write HCl. So we find out that in which uh, which reagents we will need. Now step two: know whether MgCl is soluble or insoluble. We found out that it's soluble, and know whether MgO and HCl is soluble or insoluble. Okay, so we just did it first. Now if now let's take, wait, where are we? Yes, so wait, okay, wait. You may skip this part. Okay. Okay, so let's come here. Um, so we found that there's soluble and insoluble. Okay, then we will take MgO as excess in beaker and gradually add HCl. Allow then the second part we will do is that allow the reactant to react till end point is reached. Okay. The third thing which we'll do is that remove excess magnesium oxide using filtration to obtain solution of MgCl2. Okay, but if it's asked that give us dry sample, then what we'll do, that then the solution, okay, which we have obtained, we will heat it till dryness. Okay, that's simple. But if it's said that give it as crystals, then what we'll do, we'll write that heat mixture till saturation point, allow it to cool and crystallize. Okay, obtain crystals by filtration, wash the crystals and dry within a few sheets of filter paper, or you may also write in oven or in bright sunlight. Okay, so these are some past paper points. Okay, which is very simple and earns a lot of marks. You have to explain it. Okay, and you should basically write these notes because these are very important and made by a professional teacher. Okay, which I cannot say the name, but these are made by a professional teacher. Okay, so now let's take a second example. Okay, let's take the second example. Let's take copper sulfate. So in this, the first thing which we'll do is the reagent. Okay, that which reagent is going to be used. We take copper oxide and sulfuric acid, because sulfate comes in sulfuric acid as H2O4. Okay, and here CuO. Dry. Now, if it's as dry sample, or crystal. This is the thing. Let's do it for crystal, okay? Let's do it for crystal. So add excess copper oxide to a beaker and add sulfuric acid. Okay, then allow them to react till endpoint is till endpoint is reached, or till bubbles stop appearing. So we can also write till bubbles stop appearing. Okay, these are some very basic points, but these like earn a lot of marks. Okay, now what? Filter the suspension to remove. Wait, let me do. Okay, filter the suspension to remove excess copper oxide because you have added excess copper. So the excess which does not react with the sulfuric acid will remove it by filtration. Then heat mixture till saturation point. Then that suspension which we got, we will heat it till saturation point. And sorry, that solution which we got, we will heat it with saturation point and crystallize and obtain crystals by filtration. Then what we'll do, we'll wash the crystals and dry within a few sheets of filter paper or an oven or in bright sunlight. Okay. Now let's do AgCl, silver chloride. So what reagents are needed in silver chloride? So first of all, we will see that if silver chloride is soluble or insoluble, I think silver chloride, right? So it's insoluble, as we remember from the solubility rule. Silver chloride is insoluble. Then what we'll do that we will add hydrochloric acid, okay, for obtaining chloride in excess into silver oxide in the beaker. Solid silver chloride will form. Obtain the solid by filtration as residue. Wash and dry in oven. Okay, so this is easy for silver. Till now, we have done three examples. Okay, like for example, this AgCl, okay, or silver chloride, basically copper sulfate, and also magnesium chloride. We have done the solubility rules. Okay, we have done salt making. We have done the definition of salt and what is the pH of salt. So we will do the precipitation method and also the titration method and some other things in the next class. So that's it for today, guys. Hope you understood well. And these tools are made by a classified professional teacher. So pray for that teacher because that teacher gave it for free so that you students could understand it very well. She donated these all of her notes to me so that you students could uh, have benefit from it. So do take notes from these. Stop the video in between the video. Stop it and take notes. Write it in the copy or notebook. So that's it for today, guys. Inshallah, in the next class we will do some other topics which I've said a little bit before. So Allah Hafiz and do pray for me. Okay.